Assalamualaikum and good morning. Today I'm going to brief on the data analysis 46, which is capacity of unsignalized intersection. We have done with the data collection at 3 intersection at Taman Sri Skudai. So now we want to do the analysis. Okay, so the data analysis required is 1 hour. Right. So we have 6 movements here: V2, V3, V7, V9, V4 and V5. So altogether we have 6 vehicles tally sheet to represent all these 6 movements. Okay, so the data collection was conducted for 30 minutes. But we need to do the analysis for 1 hour. So the data for 30 minutes need to multiply by 2 to get the estimated 1 hour volume for each vehicle types here, and we need to do this for all the 6 approach. Right. So once we do the estimation of the 1 hour volume for each vehicle types, we need to sum up all the traffic volume for that particular approach. So the total volume will be in unit vehicles per hour. Okay, so we have 6 movements. We need to key in the volume in unit vehicles per hour for movement number 2, 3, 4, 5, 7 and 9. And the second step will be to convert that volume in unit vehicle per hour into passenger car unit per hour. For movement number 4, 7 and 9 only. So we refer to table T62 in order to convert the vehicle per hour into passenger car unit per hour. And we assume gradient is 0%, and all these are conversion factor from vehicle per hour to passenger car unit per hour for motorcycles, passenger cars, single unit and W base 50. So for example, movement number 4 has 50 vehicles in 1 hour. Okay, 50 vehicles in 1 hour. Okay, so for movement number 4, oh no, that is the total number. Okay, this is 50 motorcycles in 1 hour. So in unit passenger car per hour, 50 motorcycle per hour is equivalent to 25 passenger car unit per hour. Okay, because the conversion factor is 0.5. And we do this for all vehicle types, and we sum up the total volume in passenger car unit per hour to get the volume in passenger car unit per hour for movement number 4, 7 and 9. Okay, so the first step was to get the volume, and the second step is to get the critical gap size. We refer to this worksheet of analysis. So for this analysis, we are referring for movement number 4, 7 and 9. Okay, 7 and 9 and also 4. So these are conflicting movement. So conflicting flow VA, the equation is given here, half V3 plus V2, and we use the volume in passenger car per hour that we obtained previously. Okay, and for each movement it has the equation that for right turn from major road, which is V4, it has a conflicting movement with V3 and V2. And for step 3, which is right turn from minor road, which is V7, V7 has a conflicting movement with V2, V3 and V4, V5. Right? Now we go to the critical gap TC. So we refer to table T6.3. So step 1, left turn from minor road is here. We look at 50 km per hour because it is a residential area with number of lanes on major road is 2, and the stop control, the signal control at the left turn from minor road approach is a stop sign. So for stop sign, the critical gap is 5.5 seconds. So we write the 5.5 seconds in here. So and then it is similar for step number 2 and step number 3 as well, but you need to look at into the respective row, which is right turn from major road and right turn from minor road. And next we go to potential capacity, CP. So in the potential capacity, we refer to figure T62. So this is figure T62. We have obtained the conflicting flow here. So the conflicting flow here will be the x-axis in the graph. And then critical gap we have obtained here. Okay, so from the volume in x-axis, we find the respective critical gap, which is TC, and then go to y-axis to find the potential capacity in passenger car unit per hour. And we do the same for step 2, right turn from major road, and step 3, right turn from minor road. And next, we have additional step for step 2, which is the impedance factor. The impedance factor is referred to figure T63. Okay, so capacity used by existing demand in the percentage in x-axis is referring to this area, which is percent of CP utilized in percentage. Right? And then from this value, we go up to the curve and then go to the y-axis to find the impedance factor value. And that value we need to put in here, P4. And the CM, or the actual capacity, equal to potential capacity. Okay? This is similar for step 1 as well. But for step 3, the actual capacity will be equal to potential capacity multiplied by impedance factor. Okay, the final step will be the analysis of the shed lane capacity. Okay, in the box. So in movement number 4, 7 and 9, we have the first column is the value for volume in passenger car unit per hour. So the volume we obtain from this table, we put in that new table. And the CM value is the actual capacity obtained in the in this part. Okay, in step 1, step 2 and step 3. CSH is actually the shed lane capacity. Movement number 4 dash no value. Movement number 7 and 9 is having a same value because it is shared lane. So we use this equation to calculate the CSH. The value for V and C is obtained from step 1 and 2 in this slide. Okay, from CSH, we calculate the CR or reserve capacity. Okay, reserve capacity for movement number 4 equal to CM4 here minus V4. And CR 7 and 9 will be equal to CSH minus the summation of volume 7 and 9. So CR 7 and 9 will be the same value. Once we obtain the CR value, we refer to table 364 to determine the level of service. Based on the reserve capacity here, we determine what is the level of service for that junction. Okay, for that approach. So in your worksheet, you need to comment on the situation. Okay, once you obtain the level of service of the junction, then you need to do some comment and recommendation on what to do next. Right. Thank you.